Okay, so we are lesson number 4, solving quadratic inequalities in 2 variables without technology. Lesson number 4. Here we are. Okay, so yesterday's lesson was solving linear inequalities. So the only difference today is that we're working with quadratics now. Exactly, which is a parabola. Okay, so for this one, we are going to do 2 different inequalities. We're going to do one where we say y is greater than or equal to x squared minus 3x minus 4, and one where y is less than x squared minus 3x minus 4. Okay? So we start these the same way we start the linear ones. So I want to find a test point, and I'm going to use 0 and 0 because that makes our life nice and easy. I'm going to go 0 is greater than or equal to 0 squared minus 3 multiplied by 0 minus 4. We get 0 is greater than negative 4. So we say, awesome, this is true. So we know that our solution set, our solution region, is this part here. Bless you. All the stuff on the inside. Exactly. So because our test point was on the inside and our test point was true, everything on the inside gets shaded. Okay? So if they ask for the solution region, what they're looking for is they're looking for a shaded part on your graph. Okay? So for the other one, we can use the same test point. So test 0 and 0 to a 0, because we're doing this one this time, is less than 0 squared. Exactly. So we know because we're working with the same numbers, if 0 is less than negative 4, so we can say, oh, nope, false. And so because our test point was on the inside, our solution region, because it was false, is going to be the opposite. Okay. I know. Okay, so Andrew, it's a short lesson. Okay. Okay, so if we flip the page, they have all the rules for quadratic inequalities in 2 variables. Okay, so Aaron, turn around. And so one of the nice things is that they're basically the same as linear ones. Okay, so our first one is still to draw the graph. The one thing, though, is that on your test, it will say algebraically find the X-intercepts, the Y-intercepts, and the vertex. Well, we learned it in quadratics, but we'll do a review today. Okay? So we'll be looking for all of these points. The other thing we have to do, step 2, is always find our test point. And then test it, of course. And then quadratics was number 5. That was rational equations. Okay. And then the third step is always to shade the appropriate area. And so we know that if the test point satisfies the quadratic, so if it's true, shade the region that includes the test point. If the test point does not satisfy the inequality, shade the part that does not include the test point. Okay, so example 1. So what they have to do is we want to follow these steps. So the first one is to draw our graph. So for our x-intercepts, we know that we can find these just like we would if we were factoring anything else, right? So we can go, okay, y is less than negative x squared plus x plus 20. And then we know we need, okay, we need two things that add to 1 and multiply to negative 20. Good catch, Andrew. Okay, so we know because we have a negative here, it's like having a negative 1 in front. And so what are two things that add to 1 and multiply to negative 20? Okay, Lucas? Justin, I asked Lucas. Okay, so that add to positive 1 and multiply to negative 20. Which one's positive and which one's negative? Yeah, awesome. Okay, so this is a nice short lesson, so I don't want anyone answering things. I'm going to ask people to answer them for me. Okay, so we can go and we'll go, okay, negative x squared plus 5x minus 4x plus 20. And then we can group it, so we know we have minus 5 minus 4, x minus 5. And so we get y is less than negative x minus 4 and x minus 5. So if we're looking for our x-intercepts, this is when we set each of these to 0. Yeah, but then when you're still putting it into to find your x, you have to put it back in, right? You just can't take that negative out and forget about it. Okay, so then we go and add x to both sides of the first one, so we get x is equal to negative 4. And then we have that x is equal to 5. Okay, so we can write these points down here. We'll go, okay, negative 4 and 5. So we have our x-intercepts. So for our y-intercepts, we know that that's when x is equal to 0. Okay, so Christine, what's our y-intercept? Yeah, exactly. So we get our y-intercept is 20. So it's going to be somewhere like that. And now for our vertex. So for the equation y is equal to negative x squared plus x plus 20, how do we find our vertex point? Algebraically. Quadratic formula gives you your x-intercepts. Kevin? Into what formula? Exactly. So we need to use our favorite form with P and Q. And so we know that P and Q is our vertex, but we're not given those points. So what do we do when we have it in? Awesome. We get to complete the square. So does anyone remember how to complete the square? Okay. So you guys really need to be quiet and pay attention because I'm making a point of doing this during the lesson. So it's going to show up on your test. Okay? So when you're completing the square, remember that, okay, the first thing we want to do is isolate these two. So we're going to take the negative out, and we get x squared minus x. Remember, we leave that big space there. Plus 20. And then we have to take this, and this is where we go, okay, negative 1 divided by 2 squared. Okay, so remember, we take whatever our coefficient is here, so negative 1, and we divide it by 2 every time, and then we square it. So we get 1 over 4. And so we get to add it and subtract it. Okay. And then so the one that we added, we want to keep inside of the brackets. And the one that we subtracted, we want to get outside the brackets. So, awesome, exactly. Because we have this negative in front, in order to get our negative 1 over 4 out, we have to multiply them together. Okay? So we're going to go 20 plus 1 over 4. Okay, so that's been kicked out of the brackets now. Okay? So for this part, we know that this can make a perfect square. So we go x minus 1/2 squared. And so this is, remember, this is where this comes in handy, because we always take this number here, and that's what becomes this one here. Okay? And then plus 20 plus 1 over 4, so 20.25. Then you subtracted it. Okay? So we know that our P is 0.5 and our Q is 20.25. So our vertex will be like right there. Okay? So remember, our P is always this one here, and our Q is that one there. P and Q. Okay. You can graph it, but yeah. So we know that our graph you could, but then you wouldn't be getting the mark for algebraically. On your test, it'll specifically say algebraically determine the x-intercept, the y-intercept, and the vertex points. So remember, because you always have it in brackets. So if it's like x plus 1/2, then you know p is negative. Okay? Okay, so we've drawn our graph. So we've done step number 1. Okay? So we still have to do our test point, but we've done the hardest part, right? It's always going to be easier from here. So I would still use 0 and 0 as our test point. So let's say test 0 and 0. And so we want to put this back into our original. Okay, so we have y is less than 20 plus x minus x squared. 0 is less than 20 plus 0 minus 0 squared. 0 is less than 20, so we say awesome, that's true. So the last step is to shade. Because it was true, we get to shade where we used our test point. Okay? So, something I did wrong in this question.
Oh, why? No!
It's not a big one, but it's one that a lot of people will make. Okay? It's not a big one, so you won't have to like erase a page of notes. Yeah, exactly, Paul. So, because our inequality does not have an equal, it needs to be a dotted line. Okay? So So this is something that we're going to be looking for on your tests. It's not trickery, it's about reading carefully and attention to detail. Okay? So make sure that when you just have a greater than or less than, that you use a dotted line. Okay? This is where people will lose. Guys, focus. Okay? So this is where people will lose marks, is on stuff like this. Okay? And I mean, like, I think, like, it's one thing to lose a mark here because you made a mistake. To lose a mark for something like this, it's like a kick in the pants. Okay, so the homework is 1 to 6.